Welcome to EENEWS video channel. I'm here with Stuart Yaniger and we are discussing OpAmps, operational amplifiers.
Then in fact you can make just about any kind of filter transfer function in the analog domain that you want to.
Yeah. It sounds a bit like having mathematics around OpAmps.
Yes,
you have
it's a pity. Equations are mandatory.
Yeah. Now this is not my strong area, but you can have differentiators and integrators, stuff all around OpAmps.
Yeah, I mean the nice thing is that most of the equations are fairly simple. They're relatively straightforward algebra. The other thing is, for standard sorts of circuit functions that you might be interested in, somebody's already done the work, and with just a little bit of searching you can find here's the circuit, here's the transfer function, here's how to calculate the resistance. It's all laid out, and sometimes it's been laid out in a chart form. It's one of the nice things about having 30 or 40 years of a lot of smart people ahead of you.
Yeah, it's all there. It's all there. Now, but these days we're doing all our calculations with digital circuits and computers and calculators, etc. But I remember that in very old days there were analog computers. Did they use OpAmps for their calculations? How did that work?
No, that's exactly what they did. Again, if you think back to the amplifier here, okay, what this circuit multiplies that input by that constant here. So it is in essence an analog computer. If I have a different constant here, it's going to multiply the input by that different constant. So I could vary both of these in theory and be able in the output to do a simple multiplication. With a slightly different arrangement of parts, I can do addition, because you're just adding voltages, subtraction, subtracting voltages. And again, the circuits are relatively simple. It's just that you need a whole lot of them to make a computer.
Yeah. You're using OpAmps yourself quite often for your experiments and your projects, yeah?
Yes. Again, at some point we've talked about analog domains and digital domains. At some point, you've got to be able to operate in the analog domain. If you've got a microphone, you have to amplify an analog signal from the microphone. If you have a loudspeaker on the other end, you have to create an analog signal that drives that loudspeaker. So on the ends of the project is really where these things these days come into practice. Again, as you had alluded to 10 years ago, 20 years ago, you had a lot of them in the middle because frequency shaping, for example, was most easily done in the analog domain. These days, it's a few lines of code. So it's irrational to have any sorts of circuits between the input and the output. Okay, so in those areas, yes, op-amps are still king. I think it's going to be very difficult to displace them. Where they've lost ground is everywhere in the middle.
Yeah. What is the weirdest application you've seen so far around an op-amp? What is your? You have an example for that?
Oh, that's a hard one. Actually, I'm working on a circuit over here for some ultrasonic ranging, and I don't know if that's a weird application or not, but it is kind of fun. I've got a transducer system set up where we've done some interesting frequency shaping in order to get shaped pulses out of it for ranging, and I've got this very nice test microphone here measuring the ultrasonic output from two different transducers, where I can use those for triangulation.
Yeah. And then at the crossroads of the way the sound travels, you measure.
Yeah, no. Again, in theory, I could take each of those outputs and immediately digitize them and do all my manipulation in the digital domain. And if I were about 30 years younger and smarter than I am, that's exactly how I would do it. Because I'm not, I actually used OpAmps to do the combination of the two ranging devices. So in that sense, you could say it's an odd op-amp application. I'm doing this application again just out of being old and ignorant.
Okay. Well, it's great to hear you talking about operational amplifiers. For me, it's a long time ago. I used to work with them, but you're using them quite regularly. That is excellent, and good to see you're having an application for that as well. Thank you very much so far. Perhaps next time we're going into operational amplifiers and a ladder network.
Yes.
Is that right?
That
Also,
will-
is it
that
also
will show
for
us how to
US?
get from the analog domain and into the digital domain.
Okay.
Where again, younger, smarter guys can take over for me.
Okay. Well, next time I still go to you, the older guy. But I'll like to hear it from you next time. The ladder network. Is that the right pronunciation? Yeah, I think so.
Yes.
Okay, excellent. Okay, well, thanks very much for your introduction on operational amplifiers.
Okay, thank you very much, Lisa.
Okay, good to see you. Thank you. Bye bye.